And if I use strong oxidizing agent with primary alcohol, then I'm going to get carboxylic acid with the same number of carbon atoms. Okay, and the carbon atoms is going to be same in all of these cases: 1, 2, 1, and 2, 1, 2, 3, 1, 2, and 3. Here we have 1 and 2 carbon atoms. Here also 1 and 2 carbon atoms. Okay, now please let us look at tertiary alcohols. Right third. Tertiary alcohols. Now, the difference between tertiary alcohols and the primary and secondary alcohol is that tertiary alcohols, they do not have alpha hydrogen. That means the carbon atom that is containing OH group, it does not have any hydrogen. That is why it is difficult to oxidize them. Please write tertiary alcohols are very difficult to oxidize. Due to the absence of hydrogen atom where at alpha carbon. Okay. For example, if I have CH3 carbon OH, and since this is a 3-degree alcohol, tertiary alcohol, it will have all CH3 groups. There is no hydrogen in the alpha carbon. In the previous cases, we had a hydrogen. That is why we removed one hydrogen from the carbon, one hydrogen from the oxygen of OH, and we used to get a double bond, and that was easy oxidation. Okay, so in that case, we have written also primary and secondary alcohols are easy to oxidize. Now, since this is difficult to oxidize, that means we have to do oxidation of tertiary alcohols in some drastic condition. That means at high temperature. Please write, these can be oxidized. These can be oxidized in acidic condition using K2Cr2O7 or KMnO4. देखिए K2Cr2O7 हो चाहे Na2Cr2O7 हो, both of them they work in a similar way. Instead of K2 you can have Na2 also at elevated temperature. As a result, next point, a mixture of ketone and carboxylic acid are formed containing lesser number of carbon atoms than alcohol. Let's see, for example, you have CH3, CH3, CH3 and OH. And when I oxidize it, first of all, what happens? One of the hydrogen from these carbons, the beta carbons, and the OH from alpha carbon, it gets eliminated. So I get an alkene with the structure CH3, carbon, CH3, and a double bond CH2. So let's suppose this is the carbon atom whose hydrogen has been removed, and this is OH has been removed. Okay, so elimination reaction happens here, and on further, this is CH2. On further oxidation, this CH2, this bond break, and this gets converted to ketone CH3, C double bond O, CH3. This CH2 gets converted to CH HCOOH, carboxylic acid, one carbon. So it is a carboxylic acid of one carbon atom. Okay, right, next. Another example, if you have something like this, and there are two CH3 groups like this. In this case, we have three beta carbons. This is also beta carbon. This is also beta carbon. This is also beta carbon. Obviously, the CH3 beta carbons are similar. Please don't write listen now. Please don't write listen now. But this beta 1 and this beta 2, these two are different. Now, when I have to make an alkene, please remember the Sedgwick rule. I will make an alkene which is more substituted. Okay, so I will make a double bond with beta 1. On first oxidation, I'm going to get double bond, this carbon atom having two CH3 groups like this. Okay, so double bond is made with that carbon atom, which is going to give you more substituted product. Now, on further oxidation, this is going to break. This carbon is going to get converted to what? It is going to get converted to ketone. I will get CH3 carbon, C double bond O, CH3 plus. Now, these two remaining carbon atoms, there are two carbon atoms, and it will be converted to carboxylic acid like this, CH3 COOH. All of you done writing this, yes or no?
Done, sir.
Done. Right, next. This was fifth, I guess. I know. Now write sixth one. Reaction with hot copper. Number one. When the reaction happens with primary alcohol. So in primary alcohol, let's say example CH3, CH2, OH. When we have copper at 573 Kelvin, it converts alcohol to aldehyde with the same number of carbon atoms. So it will be CH3, CHO, and it gives out H2 gas. So 1 degree alcohol gets converted to aldehyde. Please write these things with me. Second, we have secondary alcohol. In secondary alcohol, if I have something like this, in the presence of copper at 573 Kelvin, it converts it into ketone. So 2 degree alcohol this H2 is getting converted to ketone. Right, third, tertiary alcohol. So this will get converted to alkene. And the byproduct will be water. Done, guys? Yes or no? Please tell me. Yes, Samiha, Sara, Razan.
Yes, sir.
Done. Right, next. Send the answers on WhatsApp, okay? Let me know if you're stuck, okay? The one thing that you have to do is, first thing is identify whether it is 1 degree, 2 degree, or 3 degree. After that, you need to identify whether it is weak oxidizing agent or a strong oxidizing agent. ठीक है? और उसके बाद hot copper के पास आपके पास अभी हमने लिखा है, whatever case it is, you just try to see an answer. Primary है, secondary है, tertiary है. If it is primary, it will be aldehyde, secondary ketone, tertiary alkene. First two is correct, third is correct, fourth is correct. नहीं, fifth में Razan, the double bond will be on that carbon atom which is more substituted, right? Think in those terms. For the third one, others, please send the answer. भाई क्या हुआ आप लोग? सारा, समीहा, वाफिया, I received from someone. Sara. Third one सही नहीं है ना आपका? Sara, you have also reduced the number of carbon atoms, and also what you have, just 1 degree na. KMnO4 is a strong oxidizing agent, Sara. Fourth सही है आपका, but look at the third one. I was expecting at least 1, 2, 3, 4 सही होना चाहिए. समीहा, Samiha, Samiha. 1 is correct, 2 is fine, third is fine, fourth is fine. फिफ्थ में डबल बॉन्ड आपने बनाया है क्या? वहां पे दिख नहीं रहा है कुछ खास हमें. चलिए ठीक
No,
है.
that's not.
ऑल आर सिंगल.
Yeah.
एल्कीन बनेगा लेकिन ना. वाफिया, फर्स्ट करेक्ट, सेकंड करेक्ट, थर्ड करेक्ट, फोर्थ करेक्ट, फिफ्थ, या वेरी गुड वाफिया, फिफ्थ इज आल्सो राइट. रजान, फॉर यू द फिफ्थ वन. नो. चलिए ठीक है, अभी हम बताते हैं. सारा ये आपका थर्ड कैसे गलत कर दिया आपने? थर्ड तो सही होना चाहिए ना आपका. दिस विल बी कीटोन. देखिए, 2 डिग्री एंड वीक, तो क्या बनेगा आपके पास? कीटोन. 1 डिग्री एंड वीक, तो क्या बनेगा? Aldehyde. This is 1 degree and strong, so you will get carboxylic acid. This is 2 degree and copper. 2 degree and copper will give you ketone. This is 3 degree and copper, it will give you alkene. And alkene, see देखिए 1 2 3 4. This is the structure. Now this carbon atom, it can make bond with this 1, this 2, and this 3. And since if it bonds with 1 or 2, it is not going to be what? If it bonds with 1 and 2, then it's going to be only double bonds. But if it is 3, then it is going to be more substituted. So it will bond with the third carbon like this. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Please write this down. All of you wrote whatever you have not done correctly.
Can you scroll up? I have a doubt for the tertiary part.
This one, copper.
Yeah. I'm done.
Done. Okay. Right, next. Chemical properties of phenol. Right, next. Chemical properties of phenol. So in chemical properties of phenol, we will first of all talk about the acidic character. Right here. Phenol reacts with active metal as well as metal hydroxides to give phenoxide ion. Okay, so we have phenol plus Na. It is going to give you phenoxide ion, sodium phenoxide plus H2 gas. Similarly, when you react phenol with metal hydroxide such as NaOH, you are going to get sodium phenoxide and water. Okay. अच्छा, one thing we have already done, शायद आप लोगों को याद है कि नहीं याद है, alcohol is less acidic than phenol. We have also written the reason, and we have also written one reaction from which you can see that phenol is more acidic than alcohol. And the reaction is when alcohol reacts with metal hydroxide, then it does not give alkoxide ion and H2O. Why? Since water is more acidic than alcohol, water will give a proton to alkoxide ion and convert it to alcohol and not the other way around. Okay, so this reaction does not happen. Write with me. Since alcohol is weaker acid than water, reaction with NaOH is not possible as the H2O formed in product will convert the alkoxide ion RONA back to alcohol, and hence we can say phenol is more acidic than alcohol. Done, everyone?
Yes, sir.
Just Sara or Razan? Who is from Sahibganj? Someone told me that day, na? Razan, was that
Sir,
you?
me.
अच्छा, हाँ, तो हम साहिबगंज भी
And
कहते
sir,
थे.
I meant Sultanganj.
You meant Sultanganj,
Yes, sir.
but you said Sahibganj.
Sir, that was a typo.
Achha, that was a typo. Okay, fine. Achha. So initially when I went to Sultanganj, but this time while returning, I went to Sahibganj. Patna is a hell of a chaotic city. Phenol is more acidic than alcohol. Huh. There is a question, please write. Phenol is more acidic than alcohol. Explain using a reaction. Okay, so in this you are going to answer it like this. Phenol shows reaction with metal hydroxides to form phenoxide ion, but alcohol does not. And then you will write the reaction OH plus NaOH gives ONA plus H2O, but alcohol with NaOH does not give RONA plus H2O. लिख लिया आप लोगों ने? सुनो, प्लीज टेल मी. All of you done? Right, next. Acidic character of substituted phenol. इसका थोड़ा सा hint, we had a bit of hint in the alcohol portion also, right? But in this we are going to get into details. Please write acidic character of substituted phenol. Please write number 1. Nitrophenols. ठीक है, first of all, nitrophenol, which we have NO2 group, and NO2 group is minus I and minus M. So what are the effect it is showing? It is showing minus I effect and minus M effect. Now, since it is electron withdrawing group, all the nitrophenols, you'll write nitrophenols are more acidic than phenol. ठीक है. अच्छा, अब नाइट्रोफेनॉल में we have P nitrophenol, O nitrophenol and M nitrophenol. So for them, what is the order? Please write the order. See, first of all, we will focus on minus M. तो minus M कहाँ कहाँ चलता है? Para में and ortho में. In para and in ortho, we can see the minus M, and at meta position, mesomeric effect is not effective. Mesomeric effect does not take place in the meta position. That is why the order is P nitrophenol, most acidic. After that, we have O nitrophenol. Then we have M nitrophenol. And after that, you can write phenol. Now, in P nitrophenol, we have minus M and minus I. O nitrophenol also we have minus M and minus I. In M nitrophenol, we only have minus I. That is why it is least acidic out of the nitrophenols. Now, why is O nitrophenol less acidic than P nitrophenol? The reason, please write O nitrophenol. O nitrophenol is slightly less acidic than P nitrophenol due to intramolecular hydrogen bonding, which makes loss of proton. What is proton? H plus ion difficult. ठीक है? See the structure of O nitrophenol. Now there is a hydrogen bond between this hydrogen of OH and the oxygen of NO2 group. That is why it is difficult to remove this hydrogen H plus ion, this proton. Done, guys?
Yes, sir.
Right, next, cresol. Cresol याद है आप लोगों को? What is cresol? Cresol नहीं याद? It has CH3 group, okay? Please write CH3 group is electron donating group. It has both plus I and plus M. ठीक है? That means all cresols, whether it is ortho, meta or para, is less acidic than phenol. In this you are going to write phenol. After that, plus I and plus M में से plus I will be more acidic because it is going to donate less electrons. ठीक है ना? तो यहाँ पे आपके पास क्या होगा? Metacresol, most acidic in cresols. After that we have P cresol, and then we have O cresol. Okay, so this is having only plus I. This is having plus I and plus M both. This is also having plus I and plus M both. But O cresol is less acidic because CH3 is nearer to OH. And see, the plus M effect is same in both the cases, the para and the ortho. But since inductive effect is distance dependent, plus I is more effective. Plus I is more effective in ortho. And since it is more effective in ortho, it is more electron donating group. That is why it is less acidic. Okay? There's more electron donating group. That is why it is less acidic than all of these things. Please write this down. Write the third. Aminophenols and methoxyphenols. So aminophenols, NH2 group attached, methoxyphenol is OCH3 group attached. Now both of these are plus M because they have lone pair electrons and minus I. ठीक है? दोनों में क्या चीज है? Both are plus M, but they are also minus I. But here what is more dominant? Please write, but plus M is more dominant. That is why it will be what? That is why these will be less acidic than phenol. यहाँ पे लिखेगा. Right, next. Now since plus M or the mesomeric effect is not present in meta position, plus M is not present at meta position or at meta substituted, hence they have only minus I, which makes them more acidic. ठीक है, जहां पे इलेक्ट्रॉन more acidic, जहां पे इलेक्ट्रॉन डोनेटिंग ग्रुप is present, that means it is more acidic. याद है कि नहीं याद है आप लोग को ये सारी चीजें? हाँ ना, कुछ नहीं बोल रहे हैं आप लोग. रजान, सारा एंड वाफिया, टेल मी, यू गाइस रिमेंबर दिस?
Yes, sir.
याद है ना? तो हमने पढ़ाया था आप लोगों को. ये देखिए, decrease the acidic character, electron donating group decrease, electron withdrawing group increases the acidic strength. ठीक है, तो जहां पे भी माइनस आ रहा है, if you have minus I, है ना, if you have minus I, that means it is electron withdrawing group. If it is electron withdrawing group, it will be more acidic. यहाँ पे लिखिए M-methoxyphenol followed by most acidic is M-methoxyphenol, then we have M-aminophenol. And then you can write phenol. Why? Because minus I of OCH3 is greater than minus I of NH2. Why is that? Because oxygen is more electronegative than NH3. Oxygen is more electronegative than NH3. Sorry, NH2. Done, guys? Now, please write in methoxyphenols, the order is going to be देखिए ऐसे हम लिख देते हैं यहाँ पे. ठीक है, the meta substituted will be most acidic, followed by the phenol, followed by ortho, and then followed by para. All of you wrote this, yes or no?
Yes, sir.
Right, the fourth one. Halophenols. They have plus M and minus I. Right, next. Minus I is more dominant. All halophenols are more acidic than phenol. ठीक है, इसमें भी which will be most acidic, the one which is nearest. तो nearest कौन सा होगा? Ortho. Halophenol will be nearest, followed by meta and followed by para. ठीक है. Now, when we consider the orthohalophenols, that means when we consider, let's suppose, orthofluorophenol, orthochlorophenol, orthobromophenol, orthoiodophenol, in these substituted phenols, which is going to be most acidic, then the order is O-chlorophenol according to the electronegativity of different halides. O-chlorophenols is most acidic, followed by O-bromophenol, then O-iodophenol, and then O-fluorophenol. And then O-fluorophenol. Now you will be asking, sir, fluorine is most acidic. So sorry, chlorine is most electronegative. Then why is it not most acidic? The reason is intramolecular hydrogen bonding. See, the structure of chlorophenol is something like this, and there is hydrogen bonding between hydrogen and fluorine like this. And that is why it is difficult to lose this H plus ion, is right, due to intramolecular H bonding. Chlorophenol is less acidic than expected. Right, next. The second chemical property, second reaction. This is an easy one, a reaction with zinc dust, but important for conversions. Okay, so here you can directly convert a phenol to benzene. OH, zinc dust, and some heat. You will get benzene and zinc oxide. Another easy reaction is the oxidation of phenols. The name of this compound is benzoquinone. Write this down. Let me know once you're done.